Welcome to CW 3.4. Today we'll be talking about inverse functions. So if you ever see this notation, f of x, this is like a regular function right here. Today we're going to be talking about f inverse x. So this right here, that indicates, again, inverse. So for example 1, it says show that each function is the inverse of the other. To do that, you simply plug it in. So f of g of x, meaning we're going to take g of x and actually plug it in to f of x. So it'll look like this. 3 times x minus 2 over 3 plus 2. Now, if you're wondering how I did that, look at this thing right here. This was the x right here. It simply got replaced with g of x, which is x minus 2 over 3. Now look what happens. The 3's cancel out, the 2's cancel out. You're left with x, which is good, because that means the functions, they basically undid each other. Now we're going to verify the other way, g of f of x. Let's see what happens here. So we're going to plug in 3x plus 2, that's our f, and plug that into g, so it looks like that. And if you have a hard time seeing it, look at that blue right here, blue cloud. This used to be this x, but we replace it with f of x. Now we simplify, the 2's cancel out, the 3's cancel out. Once again, we get x. So now we can conclude, or therefore, f and g are inverses. Example 2, I'm going to show you the more mechanical way of doing it. You want to think of this as y equals 7x minus 5. All we're going to do is switch x and y. I'll make that a bit cleaner. We're going to switch x and y, so we get x equals 7y minus 5, and then solve for y. So add the 5, x plus 5 is equal to 7y, y is equal to x plus 5 over 7. Therefore, our inverse function is x plus 5 over 7. It's a really easy way to find inverse there. So a couple more examples here. Let's go to example 4. Now let's find the inverse of something much more complicated. We're going to start by doing this one right here. This is some generic function. And first step, as always, just make sure you put a y down, just so you can see it more clearly. We're going to switch x and y. So y is equal to, x is equal to ay plus b over cy plus d. Multiply both sides by cy plus d. So now we have x cy plus xd. That bottom cancels out. That equals ay plus b. Let's put the y's together. We're going to move this over there by subtracting. And we're going to move this over here by subtracting. And again, that's because I want to get my y's together. So now I have x cy minus ay. That's equal to negative dx plus b. We factor out the y. Now I have cx minus a. That's negative dx plus b. So it got pretty messy, but now it's coming out pretty clear. Y is equal to negative dx plus b over cx minus a. And let's box that. Now you might be thinking, why did we do that? What you just found is the inverse function of this generic thing I put right here. And notice how it's actually a pretty interesting formula, because the b and the c didn't move. The a and the d, notice how they switch and they negated. That's really interesting. So these two, they switch and they negate, which means if we truly understand this idea, look at the example next to it. I can actually use this to figure this out pretty fast. I'm going to highlight my A and D, and I'm just going to switch and negate it. That's positive 1, so it's going to be negative x minus 3 over x. That's positive 2. You switch it, minus 2. Pretty cool way to find the inverse. A couple more examples here. So use the graph to find the missing values. So people have a hard time with this. Let's do the easy ones first. F of 0 is blank, so clearly you look right there. That's 2. Now f of something is 0, so people would just think, okay, well, that would mean y is 0, so x must be negative 3. So this is something all of us understand intuitively, that f of x equals y. Now what you want to think is f inverse of y, that must equal x. So that's what you're going to think about as you approach these next ones. So for this one right here, think of it as y is 0, what is x? Well, if y is 0, we're right here. This must be negative 3. For this one, again, let's write y and x. It's saying x is 0, what is y? Well, y must be 2. So notice how easy that is as long as you understand this concept, that if f of x equals y, the inverse will simply switch it, where you're plugging in y and you're getting out x. And the final thing is right here, applying the horizontal line test. So highlight horizontal line test. What that test does is it checks if your function f is 1 to 1. So 1 to 1, highlight that, that's going to mean each x goes to a unique y. So it's like a more specific type of function. So it has to be 1 to 1 in order to have an inverse function. So in short, if f is 1 to 1, f has, or I'll write, f inverse exists. That's going to be our takeaway from that statement there. So simply imagine a horizontal line. I can move it anywhere, which means this is 1 to 1. This does have an inverse. Draw a horizontal line right here. It'll fail. There is no inverse here. Right here I can see there's a number of spots it's hitting. 1, 2, 3. Clearly no inverse. But this one, I can put this line anywhere, and notice we're good. This one, f inverse, will exist. Okay, that's it.